So in this question, we're told to express sine x plus 2 cos x in the form r multiplied by sine x plus alpha, where r and alpha are both constants, where r is positive and we know that alpha is between 0 and pi over 2. We're told to give the exact value of r, and we're to give the value of alpha in radians to 3 decimal places. Okay, so we can first say, our first step here is going to define alpha. And we can first say, using trig identities, that r sine of x plus alpha, using our trig identities, we know that is going to be equal to r sine x cos alpha, and then we'll add on r cos x multiplied by sine of alpha. So from this, we have that sine x is equal to r sine x cos alpha, and then we also have that 2 cos of x is going to be equal to r cos x sine alpha. So from this, we can work out that r cos of alpha is going to be equal to 1. So why does this equal 1? So we can see that the coefficient in front of sine x is 1, and then we have sine x here, so that means that's r cos alpha is going to be equal to 1, and then for the sine part, in the same way, we're going to have that r sine alpha is going to be equal to the coefficient in front of the cos x, which is 2. So therefore, we can find alpha. So we know that tan alpha is going to be equal to r sine x over r cos x. So that is going to be equal to 2 over 1. And therefore, we can work out that alpha is going to be equal to the inverse of tan of 2. And we put that into our calculator, and we remember our calculator should be in radians mode, and this comes out as 1.10714, etc. So therefore, to 3 decimal places, we'll have that alpha is going to be equal to 1.107. We'll just write in 3 decimal places. So that's step 1 complete, and step 2, we need to find r. So how do we find r? So we have that r is going to be equal to the coefficient of sine x squared plus the coefficient of cos x squared, and then we square root that. So we're going to have that r is going to be equal to 1 squared, and then we add on 2 squared, and we square root the whole thing. So that's going to be equal to 4 plus 1, which is 5, so root 5. So therefore, to conclude, we have that alpha is equal to 1.107, and that's in radians. And then we have that r is going to be equal to the square root of 5, which is the exact value of r, which we were asked for. Just to complete this question fully, we don't have to do this, but we're just going to write out a further conclusion that sine x plus 2 cos x is going to be equal to root 5 multiplied by sine. Then we have x plus alpha, so alpha is 1.107. And there we have completed the question. This question was worth 3 marks. We receive our first mark for knowing to do tan alpha equals 2 and then working out what alpha was. So we receive our first mark just about here. We then receive our second mark for working out root 5 as r. And then receive our third mark for having the fully correct answer with alpha being equal to 1.107. So just to summarize it, this mark here was for knowing to do the right process with alpha. This mark here was for having the correct answer, and this mark here was for having root 5 correct. So then in part B of this question, we're told that the temperature, which is measured in theta degrees Celsius inside a room on a given day, is modeled by the following equation here. So we have a constant 5, and then we add on sine pi t over 12 minus 3, and add on 2 cos pi t over 12 minus 3, where t is the number of hours after midnight. So we're asked to use the equation of the model and our answer to part A to deduce the maximum temperature of the room during this day. So recall in part A, we worked out what r of sine x plus alpha was equal to, and that was coming from sine x plus 2 cos x. And what do we have here? We have sine of something plus 2 cos of something. So if we let x be equal to pi t over 12 minus 3, we can use our answer from part A. So therefore, we recall our answer for part A was, we'll just put that in brackets here, we had root 5 lots of sine, then we had x plus 1.107. So that was our answer, and we knew that that was equal to sine x plus 2 cos x. So therefore, what we can say is we can say that theta is going to be equal to 5, and then we can effectively replace all of this here with this, but this time x is going to be equal to pi t over 12 minus 3. So we'll have 5 plus root 5 of sine, and this time we'll not have x, we'll have pi t over 12 minus 3 plus our alpha, which is 1.107. So that's us now got theta into something where we only have sine x. And what do we know about sine x? We know that it will be a maximum when sine x is equal to 1. So we know it can either, when it's at its kind of end points, if you like, it's either going to be 1, 0, or minus 1. Remember, we're looking for the maximum temperature, so the highest value of theta. So we know if we subtract anything from 5, it's going to get smaller. So we want to add the biggest possible value to 5 that we can. And we know that this is reached when sine is equal to 1. So we'll just write that down. So we have a maximum when sine x equals 1. Therefore, we'll have that theta is going to be equal to 5 plus root 5 multiplied by 1. So we know that that is then going to be the maximum temperature. So we know that this is measured in degrees C, or we can also put this into a calculator and just rounding to 2 decimal places or 3 significant figures, 5 plus root 5 is going to be equal to 7.24 degrees centigrade, and that's the 3 significant figures. So therefore, looking back at the question, we were asked to deduce the maximum temperature of the room during the day, and we used our knowledge of trigonometry here and substituted in 1 and used our answer from part A to conclude that theta is equal to 7.24 degrees Celsius. This part of the question was worth 1 mark, and we get 1 mark for having the correct maximum temperature. So in part C of the question, we're asked to find the time of day when the maximum temperature occurs, and we're asked to give our answer to the nearest minute. So from part B of the question, we have this formula here. So we have that theta, which is the temperature, is going to be equal to 5 plus root 5 sine, then this expression here, pi t over 12 minus 3 plus 1.107. And we said that the maximum temperature occurs when sine x equals 1. So we're writing that down. We'll just say that in part B, we said the maximum temperature occurs when sine x equals 1. So what do we want to do here? So we're wanting to find the time of day. So we want to solve for t. So we know that we want to take what's inside the brackets and make it equal to the value of x, which will give us the largest temperature. So we can then say that x is going to be equal to sine -1 of 1. So the inverse of sine evaluated at 1. And we can therefore say, doing this in our calculator, that x is going to be equal to pi over 2. So therefore, from this, we can take what's in our bracket here and set it equal to pi over 2. So therefore, we have that pi t over 12 minus 3 plus 1.107 is going to be equal to pi over 2. So now what we need to do is we need to tidy this up and rearrange to find t. So therefore, what we can do, we can say that pi t over 12 is going to be equal to pi over 2, and then we will add 3 and subtract 1.107, and then what we can do, we can multiply everything by 12, so we'll just put brackets in here, pi over 2 plus 3 minus 1.107, and then as well we can divide both sides by pi, so we will put our pi in here, and then we have just cancelled that out here, so we'll cancel that out, and therefore we can put this into our calculator, And what does this give us? So we have 12 lots of pi over 2 plus 3 minus 1.107. We divide all of that by pi, and this gives us that t is equal to 13.2 hours. So looking back to the question, we were asked to find the time of day when the maximum temperature occurs. And we're asked to give our answer to the nearest minute. So yes, we have a time here and it's in hours, but we don't normally say that we don't normally work in 0.2 of an hour. So we need to convert this into minutes, as that's what we're used to. So we can say that 0.2 of an hour is equal to 0.2 multiplied by 60. And we put this into our calculator, and this comes out as 12. So we have 12 minutes. So therefore, we can say that the time is equal to 13 hours and 12 minutes. But again, we were asked to find the time of day, and we know in the question we're told that t is a number of hours after midnight. So therefore, just to finish this off, we can say that t is equal to 13 hours and 12 minutes after midnight. And therefore, we've completed this question. It was worth 3 marks, and we receive our first mark for knowing to solve for t and doing that here. We then receive our second mark for getting to the stage where we had t is equal to 13.2 hours, and then we receive our third and final mark for converting this into a time of day and saying that the time is 13 hours 12 minutes after midnight. That's where we pick up our third mark.